For inequalities, we're gonna review. We talked about in chapter one about the inequality signs is less than or is greater than, and we talked about this being like little teeth and then of an alligator, and it was eating the bigger part. Also, we talked about the little line at the bottom is less than or equal to. We're gonna talk about numbers now. For example, I had something like x, the value of x, is greater than 5. So anything greater than 5, that could be the possible value of x. And I'm not going to say it starts at 6 because it could be decimals. It could be 5.1, it could be 5.3, 5 point anything. Anything bigger than x is the possible value of 5. But obviously x cannot be 5, right? It has to strictly be bigger than 5. But now, if I had something like x is greater or equal to 5, I'm going to say, well, x could be anything greater than 5. Once again, any number greater than 5. But in this case, because of this little line at the bottom, it looks like an equal sign. If you notice on my inequality, if I was to erase, oops, if I was to erase part of my inequality sign, it looks like an equal sign. So see here, there's my equal sign. So x greater or equal to 5. Once again, it could be anything greater than 5, but it could also be 5. The way we're going to do this when we're including a number, we're going to do brackets. When we do this, we're going to do brackets. When we're not including 5, it's just saying anything bigger, we're going to use parentheses. I know you guys have seen these things before. You guys saw it in circles, and this was like open circle and this was like closed circle, but here we're going to use parentheses, we're going to use brackets. Let's take a look. For example, write the inequality in interval notation and the graph, and then graph the interval. X is greater than negative 5, right? It doesn't have or equal to, so I'm going to use parentheses. X is bigger, so I'm going to go parentheses on negative 5, and x has to go bigger. I know for equal sign, when we had an equal sign, I always said, have the x by itself. Remember when we used to separate them through the equal sign, letters on one side, numbers on the other, simplify all this stuff. For the equal sign, it didn't really matter where the x was. For inequalities, the way I'm gonna do this, I'm gonna treat them the same way as I did with an equal sign, but I'm gonna make sure the x is on the left. And the reason why, because I'm going to respect the direction of the arrow. If the letter is written first, like our case, notice how the arrow looks like it's pointing to the right, and this thing goes to the right. My next example, I'm going to make a little more sense. Here, I want the letter on the left, so let me flip everything. I'm going to have x here, I'm going to have 3 here, right? I'm not changing the signs. I'm going to flip my numbers, but at the same time, I'm going to flip my arrow. So 3 is greater than x is the same thing as x is less than 3. The reason why I wanted the x first, because I know it's a parentheses, because it's not or equal to. Well, this is parentheses, but now it looks like the arrow is going to the left. So now I'm going to do parentheses at 3, and then I'm going to go towards the left. Once again, I want the letter first, because that way the direction of the arrow helps me to do my inequality sign. Now here, solve and graph the solution set. Remember I said we're going to treat it like an equal sign. We're going to separate it here. I'm going to move letters on one side and then numbers on the other side. But I also said I want letters on the left. So this 2k, let me move it over here as a minus 2k. My 7, let me move it over here as a minus 7. Remember, everything that moves from one side to the other, you switch the sign. 3k minus 2k, that gives me 1k. This is greater or equal to negative 5 and a negative 7. That gives me negative 12. Notice how my arrow looks towards the right now, and then it is closed. So I'm just going to go a bracket at negative 12, oops, and then goes towards the right. Once again, I want letters on the left. That way I can help, I can draw my arrow depending on the direction over here. If you notice, this looks kind of like an arrow going to the right. The only difference between inequalities and equations, when there's an equal sign, the only difference is that when I divide these inequalities, when I divide them by a negative number, or I multiply them by a negative, so when you multiply or divide by a negative, you're going to flip the direction of the arrow. I'm going to show you guys that in a minute. Well, let's talk about here. Let's say I had something like negative x is less than 4. But just to say that. Negative x is less than 4. I want the x by itself, so let me divide both sides by -1. So I know this side is x, this side is -4. Once again, whenever you multiply or divide by a negative, which it was my case, I'm going to flip the arrow, so that will give me that. Every time you multiply or divide by a negative, you flip the arrow. If you add or subtract, it doesn't matter. Like, leave the inequality sign alone. You only flip it when you multiply or divide by a negative. Now, when we have two inequalities and we have the x by itself, to begin with, we want the x by itself. If it's not by itself, get rid of whatever's around it. So if I was adding something, I would really subtract it. If I was multiplying, divide it. Right? Get the x by itself. But now for inequalities, usually for equations, we have two sides, right? The equation separated into two different sides. Now in my inequality, separate this into three sides. And then whatever you do to the center side, you will have to do it to the other sides. So if I add anything, add it to all three sides. If I multiplied anything, multiply to all three sides. I'm going to explain that more in an example ahead. Now that we have the x by itself, notice how the x is between -3 and 2. -3 is a bracket, because see my inequality sign? 2 is a parentheses. So I'm going to put a bracket at -3. I'm going to put a parentheses at +2. My x is everything in between. So there. That's all I'm doing. But I want the x by itself. Now, let's take a look at these. What if I don't have the variable, in this case n, I don't have it by itself? Remember I said I'm going to get rid of it. I'm going to multiply everything by 10 to every side. So I'm going to have -10 less than or equal to n less than or equal to 0. Right? Multiply 10 to each of these. And the reason why I multiplied it by 10, because I will get rid of the fraction. Okay. You might come and say, well, how come there's a -10? I did not flip the sign. Even though my result is negative, I technically multiply by a +10. Remember I said switch the inequality sign when you multiply divide by a negative. Technically I multiply by a positive. So here I notice that -10 is a bracket. 0 is also a bracket. And my n, my variable, is everything in between. So I'm just going to connect that. Now let's take a look at this other one. First, I'm just going to look at 4x is less than 36. I'm just looking at that. I have to divide each by 4. So x is less than 9. All right, I'll come back to graph that in a minute. Let me take a look at the other inequality. X minus 6 is greater or equal to -2. Let me add 6, so I get that x is greater or equal to 4. My first inequality, it's a parentheses, it's a 9, going towards the left. My other one, it's a bracket, 4, going towards the right. Since my two meet in the center, I'm going to do my graph over here. There's going to be a bracket at 4, parentheses at 9, and everything in between. So whenever they meet, I'm just going to say everything in between. Sometimes they're not going to meet. One of them might be going to the right, one of them might be going to the left. You guys will see those examples in your homework, so that'll be okay. Now let's take a look. Solve and graph the solution set. Rule of thumb, my answer, my answer for this, my number that I want to get should be somewhere over here, between 2 and 14. When I give you guys a graph, your answer will be there. So if you guys get something like x is greater than 17, and just to say that as an example, notice how 17 is not in my graph over here. That's pretty much telling you there's a mistake. Go back and fix it. Do not come and extend my line. Let's say this is 15, this is 16, and this is 17. Do not force it to be in there, right? If your number is not there, if I give you a graph and your number is not in the graph, you have the wrong answer. So do not extend it thinking that you guys are going to be able to fix it. Don't do that. Go back and change your work. So all right, let's take a look at here. Let me separate into the inequality side. And I said letters on the left. So first, let me combine my x's on the right. 2x minus 1x. 2 minus 1, that's positive 1x. So positive 1 on the right becomes negative 1x on the left. Then when I look at my numbers here, 2 minus 5, that's negative 3. Negative 3 on the left become positive 3 on the right. Notice how I combine my numbers, but whenever I moved it to the other side, I switched the sign. Now, when I look at this, 3x minus 1x, that is 2x, greater than 7 plus 3, that's 10. Now, let me divide both sides by 2. I get x is greater than 5. It's a parentheses, right? Not a bracket because it's open. It's open at 5, and it goes towards the right. So I'm going to do parentheses of 5. It's open, and it goes towards the right.